Okay, so today we're going to learn how to solve a system of linear equations by graphing. And the first thing you have to know what a system of linear equations is. So you know what a linear equation is. It's a line, right? There's an infinite series of points that create a line because there are values of x and y that are continuous, right? You can pick any value of x and you'll get a value of y, thus creating a line. Well, a system is two or more equations put in the same constraint. So these two equations have to be satisfied at the same time for a system, or these three equations have to be satisfied at the same time. Now, typically, when you have two variables, a system is two equations, right? You're creating a system of equations. Now, the solution to a system of equations is any point that satisfies both equations at the same time. Now, typically, when you're crossing two lines, well, how many times can two lines cross at the same place? Once, because lines are straight, right? They can't cross more than once. So typically, systems have one solution. So it's the point Okay, so a solution to a system of equations is the point where two linear equations have the same output for a given input. So they have, if you put an x into the one equation, you'll get the same y out of both, right? Or if you put one x into both equations, you'll get the same y out of both. So it's a point xy that is the same. Now, if we want to look at it the graph in terms of a graph, it's the point where two lines cross, right? Because that means that they have the same output for the same input. All right. So finding a solution given a graph is pretty trivial, right? You're just looking to see where the lines cross. That means that you put in the same input and you got the same output to both equations. Okay, so for this first equation here, for this first system here, I've got these two lines. Each of them represents a different function. Now, if you wanted to see what the functions were, we did this last week, right? We find the slope and the y-intercept. So this first function, my slope is up 4 over 1. So it's 4x. Here's my y-intercept 3. Okay, and the second one, you have you go, it looks like here, I go down 1 to the right 1 to get 2 points. So its slope is -1. And my y-intercept is -2. So the solution to these two equations, so remember, these two things represent these two equations right here, y equals 4x plus 3 and y equals -1x minus 2. The solution is where they both cross, okay, each other. So they intersect at x -1, y -1. Okay, so if I were to plug this x into this equation up here, I'd get -4 plus 3. And if I plug the same x into the second equation, I'd get +1 minus 2. And the outputs should both be the same because they meet at this point. So I got -4 plus 3 is -1, and 1 minus 2 is -1. So the output is exactly the same if I put in -1 for both x's, right? Which is what I want. I want the solution to be the same. Okay, and so why don't you pause the video real quick and try B. Just give me the solution to this equation. Where is it both the input give the same output? Alright, so notice they cross right here. Remember, when you're writing ordered pairs, you always go with the x first. So how far do I have to go down the x-axis to get to this point? So you should have wrote 3. And my y value, so I have to go down 2, so that would be -2. So your solution is 3, -2. If you plug that into both of these equations, you'll get the same output. Alright, So now that's with you given the graph. So now we're going to practice finding equations, or finding solutions given the equations. So what you're going to do, and what we're going to do, is graph them. So the first step in this is to graph both lines. Okay, so starting with my first line, I've got y equals 2x plus 2. Okay, and I'm going to graph these just like we have in the past. This is in y equals mx plus b form. So slope-intercept form, right? This makes it really nice. So let's start with our y-intercept. And I'm going to use a different color for this so we can see the separate lines. Okay, so this is going to be my purple line. Alright, so my slope for this purple line, my m value is 2. And I'm going to turn that into a fraction because I like fractional slopes, rise over run. Okay, and my y-intercept is also 2. Okay, so we always start alphabetical order, start with our y-intercept b. That's going to start at the origin, and it's going up or down, right? It's positive, so I'm going to go positive 2, graph my point. Now, for my slope, I'm actually going to look at both slopes, right? I'm going to look at the up 2 over 1 and the down 2 to the left 1, because I want to plot as many points on this line as possible. Okay, so I'm going to do both of these at the same time. So up 2 over 1, and I want to plot as many of these points as possible. Okay, and then we're going to do the same thing but going down. So down 2 to the left 1, and just make sure that they're all lined up. Right? So if you don't have everything lined up all right, then you're not going to get your solution, right? Okay, so I'm going to put my line in and just carefully draw it in so I can keep it the same color. Okay, and the reason why I want you to plot as many points as possible is because you will notice that when you do this, it makes it a lot easier to find the right point because you're not kind of guessing. You'll see where it crosses. There's no guesswork involved. Okay, so I'm going to do the same thing for the second line. I'm going to make this my red line. Okay, so my slope, m, for this one is 4 over 1. Now keep in mind, I'm going to do the same thing that I did with the first line and do the negative 4 over negative 1 as well. This is the same slope, just one is negative over negative, the other is positive over positive. Means the same thing, right? Okay, and then I want my slope y-intercept is 6b. Okay, so starting at the y-intercept, 4, 5, 6 is right here, and my slope is up 4 over 1. Well, that's going to put me off the graph. Wait, sorry, 6 is right here. Apologies. Okay, so we're going to go up 4 over 1. I've got 1 point that way. Well, that doesn't help me, right? These don't cross here. So I'm going to have to go use my negative slope. So down 4 to the left 1, down 4 to the left 1. Oh, see, right there is where it crosses, right? These two lines have the same point right here. So I'm going to go ahead and draw in my line. I don't have to go anymore. I've got what I wanted. Right? I want to see where these two lines were going to cross in the first place. So I've already figured that out, right? Using the slope and the y-intercept, we figured that out. So plot the point. Okay, so give the solution. That's the last step. Find the solution. Okay, and in this case, my solution is negative. I have to go to the left 2, so negative 2, and down 2. So my solution, negative 2, negative 2. Alright, so I want you to pause the video real quick and try this one more example. Okay, over the back, sample B, and see what you get. Okay, so what you should have gotten, for first line, I've got my slope is equal to 1/2, and your y-intercept was equal to 2. Okay, so let's graph that. The y-intercept, start here, is 2. My slope is up 1, over 2, up 1, over 2. And just keep going as much as you can so you can get as many points as possible. And remember, your other slope, negative 1 over negative 2. So down 1 to the left 2. Okay, so that you can draw on your first line. Alright, now your second line should have been same slope, which you might have noticed right away that something is a little fishy. So we have negative 1 over negative 2, except for this time, my y-intercept is 3. So I'm going to start at 3, and go up 1 over 2, up 1 over 2. So it's the same slope. And down 1 to the left 2. And as you'll notice, are these lines ever crossing? They don't. They never cross, right? Because they have the same slope. When are they ever going to cross? So in terms of finding a solution to this system, well, these lines don't cross. So you can't possibly have a solution. So there is no solution to this equation or to this system, right? There is no point that I can input for x that I'm going to get the same y out. And the reason why is they have the same slopes, right? When two lines have the same slope, it means that they're not going to cross ever, right? They can't. They're changing at the same rate, right? Especially if they have different y-intercepts, right? They start at different places and they have the same rate of change, so they're never going to cross, so there is no solution. Okay? So that's one of the types of special lines that you will run into. All right, so be ready to practice this tomorrow in class, and have a good night.